Okay, so what I'm going to be talking about today is actually two topics. I'm going to be talking about the general question or topic of building a mobile strategy in today's world, and I'm going to talk about sort of what my thinking is on what that means exactly, and I'm sort of teasing or giving away by the title, which is Writing Apps for Multi-Device Users, and sort of my thinking is that when you're building your mobile strategy, you should be thinking about the fact that people are moving into this multi-device situation. So I'll first talk a little bit about that, then I'll talk a little bit about SproutCore, and then I will show a demo of SproutCore in action and I guess let you see what's up. Before I start, I should say that everything I'm showing today, specifically with regard to SproutCore, is going to be part of the SproutCore 1.5 release, which has not happened yet. So don't go grab the latest SproutCore and try to do all of it because it's relatively new stuff. I think pretty big deal stuff, but not stuff. It's relatively conceptually new for SproutCore. So that's that. So when people talk about their mobile strategy, what happens is you can go Google mobile strategy and you get a bunch of stuff, mstrat.org and some other things, and it's basically all talking about specific devices. So when people say mobile strategy, what they really mean is something like build an iPhone app. They don't necessarily mean thinking about what mobile means for their business. And some people will talk about it. A couple of the posts that were there talked about how you should think about your your mobile strategy, in terms of making sure that your mobile department is integrated with other parts of the mobile infrastructure in your company. So people are sort of thinking about mobile as this siloed thing. They want to make sure that everybody knows what's going on, and sort of the more savvy people are trying to make sure that the mobile strategy is part of the overall concept of the company. But at the end of the day, when they're talking about mobile strategy, they're talking about make an iPhone app, maybe make an Android app. They're not really thinking about what the fact of mobile changes about applications in general. But the fact is that something has changed. Something fundamental has changed in the past few years. In 2004, 2005, maybe even 2006, almost everybody was one user pointing at one computer. And what that meant was that if you built a web application or you built an application, it was reasonable to build an application for a computer and call it a day. You can just do that. A lot of people build PC apps. Some people build Mac apps or web apps. But at the end of the day, you only have to worry about your computer. And then in 2007, what looked like a small shift, people started using iPhones. And the iPhone heralded in Android as well. So I'm showing a picture of an iPhone here and a PC, but I really mean like the general category of computer and mobile and smartphone. So it looked like a small change. People, they have this totally separate device and they're going to use some apps on it. But here's what really started to happen, something over the next couple of years, is that people started taking their iPhone, doing some stuff on it, and then moving to a computer. Or they would go to a computer and they would move to the iPhone. And this is something that Android has thought a lot about. They've demoed things like take this website or this map to your phone. But that's actually a relatively small picture. What starts to happen is that the big companies like Facebook and Google with Gmail have started to think about, okay, I'm going to have a user, they're going to be sitting at their computer for 8 hours a day using my software, then they're going to switch to their phone or vice versa. How do I make sure that their experience doesn't get lost? How do I make sure that they share a seamless experience? And then in 2010, we get the iPad, and then at some point in the future, we are likely to get TVs as well. And once we have TVs, and just to be clear, I'm not saying that I think the Google TV is going to win here or is even a particularly compelling offering. But I do think that as time goes on, we're going to see more and more devices that are not computers or even smartphones that are on the internet that you expect to have access to your applications on. And once TVs are successful, people will start wanting to move from their computer to their TV, right? They'll maybe go to Netflix and want to push the Netflix thing that they looked at to their TV, and vice versa, move something from your TV to your computer. So basically what we end up with is a growing complex ecosystem of devices that individual users are using it. And just to be clear, this hasn't even talked about the questions of different users using Android or iPhone. We're just talking about the fact that individual users have gone from being single device users, they're just using a computer, maybe they're using an iPhone as like this separate siloed device to play Angry Birds, to a point where everybody, almost every user is using a bunch of devices and they expect to be able to transition from one to another. And you can sort of, Facebook started thinking about this a long time ago, and you can sort of see this by looking at what Facebook is saying. So here's a quote from Mark Zuckerberg. He said, I think that one of the fundamental things about experiences that people are building now is that your users will experience them in a lot of different places. So maybe they'll use it on the web, and then they'll want to take it with them and use whatever mobile phone they're using. And he finished by saying, I think the big trend in 5 years is not building one app, but building quote-unquote multi-headed apps. You build something and people experience it in all these different places. And that's sort of, it's Mark Zuckerberg talking, not me, but that sort of sums up where I think things are going. I think instead of thinking about your mobile strategy as build an iPhone app, you should be thinking about your mobile strategy as how do I build an application that works seamlessly across multiple devices? How do I make it so that someone sits down at the computer, uses my application, and then moves on from their computer to their iPhone, or their computer to their iPad, or their computer to their TV or car, or whatever devices might exist that have internet access, and to the extent that my application makes sense on those devices, how do I give them a good experience? And that's fundamentally different than sort of the initial way people are thinking about it, and you can sort of see what's happening by looking at what the big players are doing, right? So the little players are still building an iPhone app. But the big players are starting to think about how do we build applications that make sense, that are an application for the user, not an application for the device, right? So Facebook is not an iPhone app or a computer app. It's an app for me or my friends, right? And that's how you should be thinking about your applications. So some problems that start to exist when you start moving from this model of a single application to multiple devices sharing the same application is synchronization is the first one. By synchronization, I do not mean data synchronization here. I just mean feature synchronization. I mean making it such that you can build an application, and when you add a feature to the desktop, it tends to exist on the iPhone and the iPad and whatever other devices you care about. So here you have version 1, right? And you want to make sure that when you rev to version 2, there isn't the version 2 iPhone app or version 2 computer app. There's the version 2 of Facebook, right? So when Facebook revs or when Gmail revs, you get a new version across the entire system. And one way of thinking about this is that you don't really have version 2, right? So you don't really have specific versions that you're rolling out explicitly to the user. But what you definitely do have are noticeable user-facing feature changes, and you want to make sure that your users are not saying, oh, I was able to use this cool feature on my desktop, and then when I went to my iPhone, suddenly I can't use it anymore. That's really troublesome. So you want to be able to build an application that you can rev in terms of features across all the devices that you care about. And remember, there's a lot of devices now. So just thinking about feature synchronization in terms of an iPhone and a computer isn't quite right either. You want to be thinking about if I have to throw another device into the mix, if I have to start supporting Android, if I have to start supporting Google TV, if I have to start supporting a totally unknown device, a refrigerator. How does that work? How do I make sure that I can throw it into the mix and then continue to provide the features that people would expect on those devices? And then sort of the second path is overall velocity. So in addition to revving in sync, you want to make sure that you can actually move at a relatively quick pace. So you don't want to be moving, you don't want to be taking years, you want to be taking months, right? You want to be able to move up in terms of versions quickly. So this can be difficult if you have totally different applications. So one strategy that people take is that they build an application for the desktop, an application for the iPhone, an application for the Android, an application for the iPad, an application for the Galaxy Tab and whatever other Android devices. This is actually fairly prevalent in the publishing industry where they feel like they need to do separate layouts for every device. So they're building a totally different app for every single device. And that means that you have to either choose to not synchronize as well or to make it take extremely long amount of time. And both of those are not super great options, right? What you ideally want is to be able to keep your apps synchronized so that you have this seamless experience for your users, right? The computer is just one place that they're using your app, and you also want to be able to add new features quickly and efficiently. And when you choose your technology, you should be thinking about what technology should I use that will meet these specific objectives. So I think there's a lot of talk about what technology to use, and there's a lot of people who are arguing that if you don't go with just native apps, the strategy of build an app for every single device that you want to support, you are doing a disservice to your users. I would argue that having a weird non-seamless experience between your iPhone and your iPad and your computer and whatever other devices is doing a disservice to your users. And I would also argue that not being able to add features quickly is doing a disservice. Now, some people might argue that don't worry about it. You can just pay for that, right? You just fund enough, big enough engineering team, and you can make that happen. And I think Facebook is basically doing that strategy. They're funding a big enough engineering team to build separate apps for every platform they care about. But I think the practical matter is that you're trading things off. You're trading off velocity for cost, right? So you should be thinking there are real user benefits to being able to deliver quick features that are synchronized across platforms that go beyond just your ability to save development costs, right? So saving development costs is a nice thing, but the user benefits a lot from using a strategy along these lines as well. So I talked a little bit about synchronization and velocity, and what I mean, and it should be clear that if you want to support these things, if you want to make it easy to quickly move up the revision of your whole application, if you want to move up your Gmail to the next version, and you want to be able to do that relatively quickly, you're going to want to have as much shared code as you possibly can. And there are ways to do this in general. I'm sure that Facebook's iOS Mac stuff all tries to use Cocoa, right? And I think you could probably try to do some code sharing in general without going whole hog. But it should be clear that if you want to move quickly, you either have to fund an engineering team the size of Facebook's or try to share some code. And shared code means two things. Shared code means the architecture and the technology. So when I say architecture, So when I say architecture, what I really mean is how do you build your application such that if I take an application and move it from an iPhone to an iPad, or I take an application and move it from a computer to an iPhone, I can share some of that code. And the way you share some of that code is by not coding the entire program as hard-coded to the display logic. So if you break apart your application into a model layer and a view layer, right, at least a model and a view layer, you end up being able to take that model layer and it's relatively portable to a new application, to a new device rather. And if you don't do that, if you have one big glob of spaghetti code, every time you add a new device, you don't get a lot of benefits of shared code. You end up having to rewrite everything anyway. And then the second point, which is the technology point, is you want to use a technology that is on all devices, right? So you can write MVC all you want, but if you're writing MVC in Objective-C and Android doesn't have Objective-C, or your computer, your PCs don't have Objective-C, then you don't really get a lot of the benefits. You get the benefits only where you can share specific technology. So you might get benefits by writing Cocoa on for the Mac App Store and for all iOS devices, but you won't get those same benefits across more devices like the Galaxy Tab, like Google TV, right? So depending on where you are, I think it's a no-brainer that you want to be using MVC, and I think it's pretty clear that you will want to be using the web stack so that your code is as shareable as possible. I want to say a word about MVC, which is just that I think it's sort of a hip term to say we are MVC. There's a lot of lightweight web frameworks that exist that claim to be MVC. And the thing about those lightweight web frameworks is that you can tell that they're not really MVC because in the model layer, they are talking directly to the view. So the benefits that I'm talking about here, and I don't want to get into a whole flame war here, but the benefits that I'm talking about here are specifically benefits that you get by writing code in a model layer that is reusable across multiple view layers, right? So I'm talking about finding ways to share code. And if your model layer does things like go into the view layer and make specific changes, then your code is not reusable. Then your code ends up being more coupled to the view layer than you would like when you want to go take the application and move it to a new device. So when I say MVC, I mean a model layer that is truly separated, where the model layer, you can theoretically run the entire model layer without the browser because it's just a bunch of JavaScript objects or Objective-C objects. And if you take MVC, true MVC, and you take the web stack, you end up pointing at SproutCore. There's a couple of options here. Another option would be Cappuccino, which is much more Cocoa-ish. SproutCore is sort of inspired by Cocoa, but it's not. I think improves a lot on the Cocoa API due to the fact that it's JavaScript. But at the end of the day, when you want true MVC that actually allows you to split apart the model layer, and you want to use the web stack, you end up with not a whole lot of choices, and one of those choices is SproutCore. So again, I don't want to go into a whole debate about specific options that exist in the world, but I do want to show why SproutCore is cool and why, if you use SproutCore in this way, you get a lot of the benefits that I've talked about. So I'm going to now transition over into talking specifically about SproutCore. So let me do a little wrap-up. So sort of the argument that I'm making in general is that we're moving into a world where people are using more and more multiple devices. And those multiple devices are not iPhone and Android, which is how most people think about multi-device situations, although that is certainly a case you should care about as a developer, right, supporting multiple devices across multiple users. But even individual users have a bunch of devices that they themselves use, and they expect to be able to go from Facebook on the desktop to Facebook on the iPhone to Facebook on the tablet to Facebook maybe on Google TV, and get an experience that works well, that is tailored well to that specific environment. And what you want to do in order to achieve that is you want to be moving in a synchronized way. You want to be thinking about the application as one big application. It's Facebook. It's not Facebook iPhone. It's not Facebook desktop. It's Facebook, it's Gmail, right? And then you want to be thinking about how you can, what the best strategy is for moving in sync at a quick pace across all these devices. So how do you build an application that is a good experience for the user, that works, that sort of travels with them, that carries with them? So, and SproutCore answers that question because it both supports a good architecture for sharing code and is a web stack technology. So that's sort of the wrap up. Now moving on to SproutCore itself. So let's talk about a specific example before I get into the deeper example. So here we have 3 layers. We have a model, which is just a to-do. And I should be clear, for those of you who are familiar with something like Rails or Django, MVC on the desktop is very different from MVC in Rails. Primarily because MVC on the desktop, every event starts in the view layer, goes out to the controller layer, model layer, and back down. MVC in Rails starts in the router, which isn't really part of the system, and then goes to the controller and view. So it's not the same paradigm exactly. It achieves a lot of the same goals, but don't think that the exact way that MVC works on Rails is going to be transitional to any MVC framework on the web. So pretty much anybody who even claims to be MVC does something different from what Rails does or what Django would do. So here we have a model layer, which is basically just a bunch of JavaScript objects, and that's really the core thing about the model layer, is that it doesn't really know anything about how things are being represented. It purely knows what I would refer to as truth. There is a single location in your application that represents the current truth. You then have a controller layer, which helps views manage groups or specific elements. And then you have a view layer, which is actually reflection of truth onto the page. So often you may have a single element in the model layer reflected on multiple DOM nodes. Usually the way that would work is that the model layer would be represented by a controller. So that model will be represented by a controller, which would then be shared across multiple views. And I'll show you some examples of that shortly. So here's an important thing. So here we have a view, which is a create to-do view, which would have like a place to type in text. And we have a to-dos view, which is a list, shows a list of all the views. And both of those things talk to the to-dos controller. Sorry. So when I say both of those things talk to the to-dos controller, I mean that they are 2 elements that are working with the same group of things, so sort of same group of truth, and they are working they're coordinating through this controller object. And what you want to do in practice is you want to say that this particular view, this to-dos view, is the same as this controller. So they represent the same data. And in SproutCore, it's actually really easy. And again, I'll show a demo in a little bit that has a much more fleshed out example. But in SproutCore, anytime you create a new object, you can use key binding. And you can and that basically tells SproutCore that whenever the object on the right side changes, make sure to update the object on the left side. So essentially, that means that you can make changes to truth and have them automatically be reflected in DOM without having to do any additional work. I'll show how that works shortly. So in this particular case, we're using a template collection view, and what that means is that when the controller's content changes, update the view automatically. So if I was to add a new element to the controller, with that single line of code that I showed before, it would automatically update the view. And here's pretty much how that works in practice. So you have a create to do view, and there's an event called insert new line, which basically means I hit enter. And what I do inside that insert new line handler is I create a new to do object, and I grab the value out of the current input box, and I push that object onto the to-dos controller. So now the to-dos controller is out of sync with my normal view momentarily because it has a new object which is not yet reflected in the view. And what happens is that because I set that binding, without me having to do anything else, that new item will get reflected properly in the view. So I won't have to do anything. All I did was push something onto the controller, and now my list view will automatically get updated. So the core concept here, the thing that SproutCore is doing that's very cool and sort of unique actually, is that you don't work with the DOM most of the time. You can of course do anything you want with the DOM, but most of the time you're working with underlying data and you're expressing declaratively in the view what part of the truth you want to be reflected here. And something that I found was a bit missing. So I started looking at SproutCore about 6, maybe 9 months now, and I really like this idea of you have this source of truth, which is your model layer, and you declare how that gets reflected on the view. That was pretty cool. But I felt like there was something missing about this declarative approach, and that what was missing was that there was no way to declare that, to sort of specify the HTML that would get emitted in template form. So what you would have to do is you would have to create a render method. That method would create a bunch of strings, and then there would be a separate update method which would give you the opportunity to update the view based on whatever truth had changed. So again, it's sort of the same approach, right? Where you get access to truth, you get notified when truth changes, and you make the change. But I felt like we could make it even more automatic, like we could make it more declarative. So here's what a to-dos view looks like. It's a handlebars template, and there's just sort of HTML with a bunch of handlebars helpers. So what pound collection does there is it says that this chunk of HTML that's inside of the collection gets attached to the class todos.todolist view, and for every element that gets added to the underlying controller, which I will show you how it gets wired up shortly, the part that's inside the block, that's what you should show for it. So make a checkbox, attach that input to the checkbox class, and make an input. Create a div, and then bind property title is bind property is essentially a special thing that says, right now, put in whatever the title is, and if the title ever changes, automatically update it. So you don't have to really worry about updating that HTML anymore because you said whatever the underlying truth is, use it now, and if it changes, update it automatically. And then, again, there's a view at the bottom, which is a destroyed to-do view. Sorry, I already said this, but basically bind property title, it's sort of like just saying title, but it will bind automatically to that property. I should say bind property, that particular API is probably temporary. It's pretty long, and there's probably no good reason why we couldn't either make it much shorter or go away entirely. So that's probably going to change before SproutCore 1.5 or maybe at some point after that. But the underlying idea is that in your template, you could express the idea of use the title of whatever I'm inside of right now, and then if it changes, update this automatically. So if the title property of this to-do item changes, automatically update this part of the DOM. And here's sort of what's happening under the hood, right? If you go and you say, get me the first object in the to-dos controller. So the to-dos controller is basically just an array. So you can grab the first object out of the to-dos controller, and you can set the title to be other title. And what that will do sorry, what that will do is automatically update the title that I showed in the previous slide, right? So this over here, bind property title, if I was to go into the console and do this, it would automatically update the title for the first object that was displayed. So essentially what's happening here is that SproutCore templates give us another way to declare bindings to the view layer. So in the past, there was a pretty good binding system that was used rather efficiently to bind the model layer to the view layer. And SproutCore or templates, which is what I showed previously, which are a feature coming with 1.5, they give us another way to do it in a even more automated fashion. I want to show you one more thing before I get into the demo, which is basically a little bit of sort of what is going on under the hood to make all this stuff work. So I make an empty hash, which is an app, and then I create a person. So SCObject.extend basically subclasses SCObject, and I make a first name and last name as null purely just for documentation purposes, but not necessary. And then I specify full name. So full name here is the interesting thing. So SproutCore's property lookup basically lets you say either get something if it's a property directly, or you can declare a function which is a property. So in this case, I declared a function called full name, which is a property. I say it's a property, and I return first name plus space plus last name. And what's happening on the last line there is that I'm saying that it actually depends on two properties, first name and last name. And then I specify that it's cacheable. So when I specify that it's cacheable, that means that if the first name and last name don't change, you can just use the same result over and over again. It also means that if the first name or the last name changes, you should notify anybody who's bound to this property. So what does bind to this property mean? So what we do here is we'll just make a person, app.currentPerson is person.create cats, right? And then we can make a view and we can specify, and this, you can do this for any object. So any object can get name binding, anything binding. And I specify the name binding to be app.currentPerson.fullname, right? So I'm binding the name property of this view to the full name of app.currentPerson. And basically what that means is that whenever I go and update any part of full name, any constituent part, so in this case it's first name and last name, so I update first name or last name, this binding will get automatically resynced. So if I do app.currentPerson.set last name cats exclamation point, what that will mean is that the name, that SproutCore will behind the scenes update the name property of the person view to be Yehuda cats exclamation point. So that's sort of a cool thing that's happening behind the scenes, and it sort of makes everything work. Sort of bindings are an interesting thing if they were just regular properties, but once you add the opportunity to create computed properties, they become a lot more powerful. So now what I want to show you is a demo, and I'm going to be releasing this in the next couple of days. It's something that I've been working on with Tom Dale here at Strobe, and essentially what we did was we looked at the Backbone.js to-dos demo because we thought it expressed some really nice things about building simple applications. Specifically, what was cool about the demo is that it's complicated enough to not be super trivial, but it's still simple enough to get some interesting concepts out of it. And what we wanted to do, and we're still sort of hot on the trail, is see if we could significantly cut the number of lines of code that you need to build the app in SproutCore. So obviously, SproutCore has some code that is bigger than Backbone's code. It's not as much bigger as sort of it was in SproutCore 1.4. SproutCore 1.5 will have a core that's much smaller. But there's certainly going to be more code in SproutCore than there will be in Backbone. But what we wanted to see is if we could significantly reduce the number of lines of code necessary to write the same app in SproutCore in terms of app code. And we've done that pretty well, and I want to show you that. Okay. So first of all, let me actually go here. So SC server is basically a command line tool like your Rails server that boots up a server, and it gives you access to localhost 4020. So I can, say hi. Right? And I can check off any particular item, and you'll notice that when I checked it off, it struck it out, and now it says clear one completed item, and it reduced the number of items left to 2. And if I clear the one completed item, it will go away and it sort of does exactly what you'd expect. And I can click X to remove things, right? So it's basically, it does pretty much what you'd expect, and it's pretty much a clone of the backbone to do. And that's, again, purely because we thought it had some nice properties that we wanted to see how well we could do. So let me take you through a couple things. So first of all, here's the template. Right now the template goes inside of your index.html. We're going to be adding a feature to the build tools that lets you store it as a separate file and precompile it and everything for you. And this is sort of exactly what I showed you before, right? So there's a view with a create to do collection, another view for stats view, and inside that there's a completed view, and there's some blind properties here, right? So essentially what you're doing here is you're just saying there's a bunch of pieces of HTML, and you're expressing for the pieces of HTML how they are attached to specific SproutCore classes. And the way you should think about SproutCore view classes is that you will want to use the SproutCore view class for every discrete thing that you want to handle events on. So if you would like to handle events on a button or the destroy to do little button, right? So here, right, if I say hello here and then I click that, that's something that I want to handle events on that specific thing. So I want to make that into its own view. And now let me show you the code. Whoops, that's the CSS. We pretty much ripped off their CSS, by the way. So let's go, I'll just walk through it. So in terms of the model layer, SproutCore has some pretty nice model tools, but we basically just use the regular SproutCore objects. SproutCore objects pretty much have all the observing and binding features that every other object has, so we could just use those directly. So we've created a new class called to-dos, and that thing has an initialization, and this sort of is what Backbone does, right? If you don't set any title, it's empty to do, right? So it's empty to do, ... And then we just documented that there are two properties that we expect to exist. Controller is, actually let me head down to the view. So create to do view is this view over here, right? It's this typing in view. And what it does is it listens for two events. It listens for insert new line and cancel. And the way that it handles that is that it mixes in a small mixin called text field support. Text field support basically just provides a couple of non-standard events that you could listen for. So instead of listening for key up and saying if key code equals 13, you could just listen for insert new line. Of course, you could just listen directly for key up if you want, but we wanted to make it a little bit easier. So you can listen for insert new line, and then we're doing pretty much exactly what I showed before, which is that we are creating a to-do with the title of the current value, and this .getValue is a property of, is provided by text field support. And then we go to the controller, push the to-do on, and then set the input to an empty string. So this $$ is basically just a jQuery object that's scoped to the current view. So, right, if we look at, this thing here, you see that there's a view, an SC view, and this $$ is basically just a jQuery object scoped to this view class. And we go and we grab the input out of it, and we call empty. We make it empty using regular jQuery methods, and then we return true. And cancel is, actually this is the one feature we added that Backbone didn't have. Cancel is basically the escape key. And we also grab the input, we set the value to empty, and we blur. So if I go and I type in hello, and then I hit escape, it will blur out. To-do list view is a special kind of view called a template collection view, which is basically, it's a regular template view, except it's designed for rendering collections. And whatever you bind it to, it will automatically render the child. And I'll go back to the HTML real quick. It'll render the child for each element that gets created or removed. So if I create a new element, it'll automatically render the child block for that new element. So let's take a look at that real quick. So here we have collection, right? We have collection, and we're pointing at to-dos.to-do list view. And basically the way the collection helper works is that this block of code over here gets rendered once for every single element in the list. And you don't have to do anything. If you're using a template collection view, you don't have to do anything to get this behavior. You basically just have to bind to some array, and it will be magic. It will do the right thing. So what we're doing here is we are binding to the to-do list controller. And like I said, over here where we push the object, that's all that needs to be done in order to get it to render a new element for each child. And basically example view is just, it's a template view that is the class of each individual child. So in this particular case, you don't always need a full class for example view. Sometimes you're just rendering a piece of text that has no behavior. In this particular case, we wanted to give it some class names. And we also want to do a thing when isDone changes. And this is sort of an example of truth reflected on view as opposed to doing some special thing, sort of listening for events, right? So what we do here is we create a new isDone.didChange property. New isDone.didChange method. And we tell that method that it observes the isDone property on the content. Every element rendered inside of a template collection view gets a content, which points back at the object that was originally being used. And we basically just use jQuery again to toggle the class of done based on whether or not the content is done or not. So if I go and click this over here, what's essentially happening is that what's essentially happening is that the done property is getting modified, and I'll show you how that happens shortly. But that happens sort of elsewhere, and then because that property changed, because these sorts of truth in the world changed, we got notified and we got the opportunity to make a small change. The way that happens is by this other view here called checkbox. So that's this over here. We have a checkbox with an input, right? And in that checkbox, we just observe value. So we're observing the value of the checkbox. This uses SC checkbox support, which is, again, a tiny mixin that just handles providing a value property and I think a change event or something. So when the value changes, we walk up the view hierarchy, we get the parent, we set the content isDone to the value of the checkbox, right? And again, all we did here is we set a underlying object isDone property to true, and we didn't do anything else. And this observer will end up firing, which gives us a chance to go update the view representation. The destroy to-do view basically is a template view without any special mixins. It's just a little div, and we make it a span because that's what CSS we have. And then on mouse up, we just go to the controller and we remove an object. Again, we grab the content out of the parent view. So this destroy to-do view, is over here, right? So we're inside of a collection. So we can walk up the parent to get basically the class of that example view over here. And we can basically get that content and remove it from the underlying to-do list controller. And again, if we do that, right, if I click this X over here, you can see that all I did was remove the object from the to-do list controller. And because I'm using a template collection view over here, it automatically gets removed from the element. So this is actually pretty cool. It basically means that most of the time, with only a couple of exceptions like this setting of class thing, you use implementations that know how to handle binding to specific types of data structures, and you automatically get the DOM updated as desired. Stats view basically is the end. So I'll just show a couple more things and then take questions. So basically, stats view is a view that is here, right? So we have a view called stats view, and then we bind the property remaining. We bind the property remaining word, and then we use a view called clear completed view, and we bind the property completed and bind the property completed word, right? And basically, what we can do is we can create these properties directly on the view. So we create remaining word, and then make it a property based on remaining, which is actually going and getting it out of the controller, which I will show you shortly. And then it's just returning. Then for remaining word, it's returning item if it's one, or items if it's more than one. And then basically the exact same thing happens for clear completed view, right? We ask the to-do list controller for the completed, or rather we bind to the completed, and then have the completed word property be depending on that completed and do the same sort of thing here. And then for the clear case, when mouse up happens, we just call clear completed to do on the controller. So in this case, we're actually making pretty heavy use of the controller. So let's take a look at the controller before I take questions. Just go back up. So the controller basically has 3 things going on, or 4. One of them is that it starts with an empty array. So an array controller is basically a proxy for an array. So it looks, feels, tastes like an array, but proxies everything to the underlying content. So we create an array, an empty array to start with, and then we could set it to other things later, as we showed below. Then we have 2 properties. We have the remaining property and the completed property, and both of these the remaining property rather is using a new feature that we just added, which is pretty cool, which basically lets you say that this property depends on the isDone property of all the children. So if any of the child isDone property gets changed, this property will get updated. That basically means that down here where we set isDone, let me go find it. So when we set isDone over here, that will result in the remaining property getting invalidated, which will then propagate it down here, right? So here we have the remaining binding. So what that means is that all you have to do is set isDone on an underlying object, and everything will work. It will propagate all to the right places in the view. And what we're doing here is we're just getting the content, which is the array, and we're filtering it based using, this is a built-in SproutCore method called filter property, and basically we're filtering by isDone false. So we're getting all the elements who are not done, so that's the ones that are remaining, and we're getting the length out of that. And as long as you don't add a new object, or as long as the underlying property, as long as the underlying isDones don't change, you can call remaining over and over again, and you'll get back the same value. You don't have to do this work. And completed basically is a property that depends on length as well as remaining. So which means that it will also end up depending on each that is done. And it goes and gets the length and subtracts out the number remaining. And again, because this property is cacheable, it doesn't end up having to do this computation over and over again. It does the right thing. And finally, clear completed to-dos is the method that we called from here, from mouse up in the clear completed view. And it's very simple. It just gets the content, it filters the true isDones, and then calls this.remove object. And again, an array controller looks, feels, and tastes like an array, so you can call SproutCore has a bunch of methods which you can use to manipulate arrays that will be aware of observers and bindings. So you want to call remove object, not pop, right? And you basically go through all of them, you remove the object, and every SproutCore enumerator takes a second parameter, which is basically the this that you should bind to, and that's sort of how we get around the general JavaScript problem of this not having the right behavior. So I think that's all. What you'll notice, sort of, I'll say my closing before I take questions. What you'll notice here is, first of all, there are actually fewer lines of code than Backbone, actually quite a few fewer lines of code. But really the thing that you should notice now that we've been through all this code is that there is very, very little direct DOM manipulation, right? Everything is declarative. Everything is, you say that this view is attached to this piece of underlying model or this controller. And then this view, when you make this change, go modify the underlying model object, sometimes through a controller, right? And then what happens is that because you declared everything, the DOM updates itself. There's a couple of cases, like I said, like over here, where you have to do a little bit of DOM manipulation yourself. But if you think about it, there isn't all that much DOM manipulation, and it's actually very decoupled from the process of actually making changes to the underlying DOM nodes. So for instance, if you wanted to make another way of changing isDone, if you, for instance, had a master detail pane and you were allowing people to edit each one of these individual DOM nodes by themselves, if they checked off isDone on the detail pane on the right side, you wouldn't have to do any more work to have this just work, to have it update this thing. So there's a lot of benefit to that. So I think that's pretty much all I have to say right now, and I think I'll take questions.
Okay. Hey, Yehuda. Yeah. Thanks so much for that overview. Where am I hearing myself echo?
No problem.
Okay. Do you want me to read you the questions, or do you want to stop sharing and read them yourself?
I'll stop sharing and read them myself. although I may end up needing to share
Okay,
again
I'll
if you're
take us.
asking them questions.
Okay, well, I'll take us back to our lobby so we can look at our
Okay.
pictures here. And
Okay, so the first question is John
all right.
David Garza. I'm assuming I'm looking at this Q&A. So does
Yes, you
AppSync
are.
also trade
That's
off
right.
device-specific features? So I can't really speak for every. Hello? Okay, great. Question,
Go
does
ahead.
AppSync also trade off device-specific features? Can people hear me?
I can hear you.
So
I
the
think
question
people
is, does
can. Yeah.
application sync The question is, does application sync also trade off device-specific features? So I can only speak for the way we think about this at Strobe, but I think it's the right way to think about it, which is that it doesn't, because of the fact that you don't necessarily try to take one application and put it everywhere, right? You're trying to share as much code as possible. So the goal of application sync isn't about write once, run anywhere. That's sort of a discredited idea. The goal of application sync is to be able to have the part of your code that's different per device be relatively small. So you're sharing a lot of code, and the app-specific features are small. So if you wanted to, for instance, use a camera on iOS, and you needed to use PhoneGap to achieve that, it would be okay, right? But the amount of underlying code that has to change to make that work is relatively small. If you wanted to do something special on the iPad, right? Have a totally different layout. You would be able to make a lot of use of the existing model and maybe even controller layers of your code and just rewrite the view code. I should point out that in my demo, there isn't much model layer here, but in real apps, there's a big model layer. And so you can take the model layer and sort of use it for a lot of things. So I wouldn't think about application sync as write once, run anywhere. I would think of it as write once, adapt anywhere. So that's question one. Question two is, good way to build and dispatch views that are optimized for different devices, iPhone versus iPad, bundles, question mark. So Peter's actually working on a pretty good, on something that we're working on Strobe called Spade, which we'll be talking about in the near future. Just basically improving general SproutCore distribution. And we're sort of trying to make SproutCore code distribution and sort of this problem of how do you deal with devices having different requirements, how do you solve that problem? We're trying to solve that in a very similar way to RubyGems, because we think that Ruby's RubyGem system is pretty kick-ass, and we want to have that for SproutCore. So Peter, who's been, I think, answering questions this whole time, has been working on it. Has Handlebars been incorporated into SproutCore? Yes, so Handlebars is now a framework in SproutCore, so until we have Spade up and running, we still have the sort of framework concept where there are individual frameworks that are that provide features. So there's a Handlebars framework, and that is used by Core Foundation, which is a new framework, which is trying to be a smaller SproutCore essentially. So regular Foundation and regular desktop depend on Core Foundation. So we're trying to shrink the amount of code necessary to get started. That depends on Handlebars, and that is what is providing the template layer. How is ACE2 coming? I do not know the answer to that question. I bet you Peter would know the answer to that question. I believe that it's coming along, but I believe that it's being worked on mostly by people inside of Apple. So it sort of has to go through their post-spec process to be seen. I think a lot of it is already in master, but I could be just totally making that up. I'm seeing a question right now in chat, which is, will SproutCore Ember be compatible with jQuery 1.5? Yes. Maybe even today I will integrate jQuery 1.5. Is the source for this demo on GitHub? It will be early this week, so today or tomorrow probably. What is the difference between the init method and just defining a default value for the title property the way is done is defined? So why did I do that? That is a very good question. I may not have had to do that. I think I didn't have. Oh, I know why. So basically, no, I have no good excuse. So it could have just been a default property, I think. Todos.todo.create won't work currently. I would need to know more about what it is that you're saying. Hold on, I've lost track. How does SproutCore work with small cache limits on mobile devices? So I've given sort of a bunch of talks on this actually, and mobile devices have much bigger caches than you are aware of, via special new features, most notably cache manifest. So first of all, SproutCore is not like as big in terms if you just use Core Foundation as you think. I think we're down to 50K minified and gzipped or something like that, which is not much bigger than jQuery. So not super huge. But second of all, if you use cache manifests, browsers will do a good job of hard caching relatively big files. I don't know, I'm not sure what the limit of that is, but SproutCore is in the tens of Ks, not in the like megabytes, so I wouldn't worry about hitting a limit there. Is there a book for learning SproutCore yet? I think we're working on one, and we will have more on that soon. Will Amber be usable without the SproutCore build tools? That is definitely a goal. I think the SproutCore build tools are a win over not having them. I think a lot of the problem today has to do with just getting a Ruby environment up and running that will work and make things sensible, and that is going to be resolved for 1.5. So you'll just get a PKG or an MSI and install it, and you will have stuff. But at the same time, I think we do want to make Amber.js available as a standalone thing you could throw in a script tag. So sure. Does SproutCore have something like NS notifications? So there is obviously the event system, which is sc.event. I think Alex was wanting to work on a notification, something more exactly like NS notifications, but you should be able to use the SproutCore event system or the jQuery event system to achieve similar goals. Will SproutCore be able to use WebSockets? I don't see why not. If you're asking if there's going to be a WebSocket library, nobody on the core team is actively working on one, but you're certainly welcome to, and we'll be happy to help. Can I build a secure e-commerce app website with SproutCore? Yes, and there are people doing that. Question, what about IE support? So SproutCore today supports IE 7 Plus, and we should be able to support Windows Phone 7, although Windows Phone 7 is some weird IE 7, IE 8 thing, so I'm not exactly sure. We have not tested it, but assuming that it's not crazy, it'll probably work. So, but we do support IE 7 and IE 8, and we will for the foreseeable future. Last question. Can we leverage jQuery mobile effort from SproutCore? I was actually just talking about this morning. I think it would be a little potentially weird today, but I think it would be possible to build a reasonable bridge that would let you use jQuery mobile for sort of the like basic view layout, and then use SproutCore for binding. So hopefully you saw today was that there's a lot of win in being able to sort of just say, here is the view that represents this piece of data, and then please go keep updating the DOM whenever the data gets updated. jQuery mobile is conceptually different. It's basically you give it an HTML page that has everything filled in, and it goes. And they're orthogonal enough problems that it might be possible to make it work. And I definitely think there is some value to just like getting a simple transition sliding CSS thing going. Thoughts on web workers in SproutCore? I think actually there are cases in SproutCore where it would be very useful, where you're, for instance, crunching a lot of data. So you get like, you have 1,000 or 10,000 items that you want to crunch to be able to display a summary, even though you're not displaying all 10,000 items. I could easily see web workers being cool for that, and people have talked about making the SproutCore data store work well with web workers. What is your opinion about using CoffeeScript and SproutCore? I think if you like CoffeeScript, you should use it with SproutCore. I don't know what the status of this is, if we merge it in or not, but we are definitely supportive of people's efforts to use it, and I believe there is either a pending patch or a already pulled in patch that makes CoffeeScript files work fine inside of the SproutCore build tools. Any plans to host a SproutCore training event via Strobe Camp? Not exactly sure what Strobe Camp is, but Strobe in general definitely has plans to do more SproutCore training. So keep an eye out. We will have more on that. Okay. Is that it?
I think that's it, Yehuda. Yeah, so thanks so much for your presentation and for going through all those questions so well. So I really appreciate you doing this today. And thank you everyone else who joined us today. I know we had a few audio issues, and I appreciate all the people who put up with them and waited till they cleared out more or less. So we do really appreciate that. And believe me, we're always trying to improve, so please bear with us. And I just want to say one more time, thank you to everyone who joined us today, and I hope you'll join us again in the future. We'll get the link to the recording out to you probably within a couple days. Oh, thanks, Cody. Thanks, everyone. Bye-bye.